Hi, I'm Alexander Moore. I'm a PhD student at Luleå Tekniska Universitet, which is in northern Sweden, and this is part of my project that I'm doing currently. Phobos G is the name of our experiment. It is a penetrometry experiment based on my PhD. So we have a bunch of linear actuators and a robotic arm to test penetrometry in a bunch of different samples. We currently have a bunch of glass beads and JAXA simulant that they sent to us, which should simulate potentially Phobos' surface for the upcoming MMX mission. So throughout the parabolas we'll be sort of pressing a button, and all the linear actuators and the robot arm will put a penetrometer into these samples and test to find the force reaction from them. We'll be varying the speed of penetration, obviously the samples and the tip shapes. So we have a number of different tip shapes to understand the characteristics behind them and if there's any links or trends between them. And obviously in 0G, because you don't have many opportunities to do penetrometry in 0G on the ground. A lot of the data we have is empirical. It's a lot of simulations and stuff. We don't actually have much. We did a bit on Apollo. We did some penetrometry on the Moon, and in the Huygens mission we also did some on Titan. But since then we haven't done too much. We've done a little bit with Bennu and Ryugu, but obviously you can't really simulate penetrometry in 0G unless you go to space, go to the ISS, or you do a parabolic flight. There is potentially drop towers, but the parabolic flight gives us a lot longer time of 0G, about 22 seconds. Meanwhile, a drop tower will give us only about 8 seconds. So this is why we have to go do this, because the slowest we run is at 3 millimeters per second. So if we wanted to go 45 millimeters, it takes 15 seconds. So that's why we need a parabolic flight for that. Potentially, if this robotic arm works in a 0G thing, you could have it on the ISS working up there. You could have it on a different planet, because once you set the gravity, it's actually this is a lot harder because this is a lot more varied gravity. But MMX actually have a probe with a robotic arm that will be doing the penetration and coring sample on Phobos. So this is sort of giving them indication of what they might feel, what they might see there, and can help them in the future. And then obviously future work for myself is maybe even designing a better penetrometer that can measure sort of more accurately what we're seeing in these samples by changing the tip shape, changing the speed, and changing the method of our penetration.